Good morning. In this video, we will talk about the fork function. And we know that when you do a fork, a child process uh, is created, which is exactly same as the parent, is almost like a cloning. And this PID will have a value in the parent code of the child process ID, the child process ID. Whereas in the same PID in the child will have 0. We saw that, right? And so you have two separate code, and the child, when you call get PID, it'll print the process ID of the child, and get PPID, that is get parent process ID, will print the, the child's parent, which is this guy, right? So let's give some numbers for now, okay? Let's give some numbers so that way, uh, and so let's pretend this is 200 ID, this is 205, for example, and the bash that program that's running on the back end, which launches this particular parent, right? Let's pretend the ID is 100. So when we print this get PID, in the parent, it'll print 200, right? It'll print 200 because that is a process ID. And when you say print get PPID, we'll get the value of parent is 100, right? Because that's a bash. Whereas here in the child, when you say get PID, and the value would be 205, and get PID, now you guessed it, right, will be 200. So now pretend both are executing the code, which is a similar code, and pretend the parent has finished its code without waiting for the child, okay? That is, the same code runs through and completes execution, whereas the child is slow in getting to complete. So what happens when the parent finishes its program, the operating system takes its memory out, right? So this process doesn't exist anymore. And so now what happens when the child prints get PID, there is no such thing as 200. 200 is gone, isn't it? 200 is no more. So you may think that operating system should assign it to the bash process, but bash says, I'm not going to take any of those responsibilities. So what happens is this get PID will result in a value of 1. And who is 1? 1 is the root process, the init process, the very first process that the operating system creates, which is a value of 1. So we will prove that right now using the simple program. You go here and we will simulate that, okay? This is a simple program. We have a fork, and when we say PID equal to 0, I make the child go slow. That means I'm going to put him to sleep for 1 second, and I'm going to print, as you see here, I'm going to print the value of the PID and get PID in the child process. The parent process will also print, but as you see, he's not sleeping anymore, right? And there is no wait. There's supposed to be wait here, okay? The parent has to wait for the child process to terminate, but that guy is not here at all. Okay, so let's go ahead and see how that works. Okay, let's compile this program and you see run it. Boom, and you see the parent process is PID 2180, and if you do a PS, you see the bash process which we saw is 20223. That's what the parent process we talked about, right? We talked here. Oh, the one we removed, right? And that's the bash. And you see the child which printed after 1 second. The ID is 21281, but its parent process is 1. The reason is the parent has terminated before the child could finish it. So you have to, whenever you see a process is terminated before the parent, it's always a good idea to check the process ID, the parent ID. So if it is 1, you know that the child has taken time to finish it before the. So in these situations, you have to make the parent wait for the child to wait come up. So there is a simple code, right? Just wait. If you do that, and now you print, and it can even wait for 5 seconds, doesn't care, right? So let's go ahead and compile it and run it. So this is parent is now waiting for the child. You see now the parent is 21354, the parent for the 21353, and the parent for the parent is 20223, which is the bash. You see that? And the child ID is 21354, and the parent is this guy. See that? So the wait is a critical function that you have to plug it in the parent process. So that is the main reason why we use the wait command function. Okay, and this wait, if you poke this value of the wait, it will tell you how did the child terminate. Also, it gives you the status of how the child terminated. So that's a different video. Don't worry about that. And here in the next video, we will talk about the XLCL commands. All right. Thank you.